So I'm Ken O'Neill again. So Hishem and I are actually going to present a short presentation just to close out the day here. We're going to be looking at applications for Microsemi's space products and some of the ecosystem that we're putting together both within Microsemi and with our partners to help designers and engineers in the space community to be successful with the missions that they're working on. So the structure of the talk is, first of all, I'll talk a little bit about our vision for space, and then Hishem is going to come up and talk in more detail about the ecosystem, how we're expanding it into the space community, some of the work we're doing with our partners and the IP that they have. We'll look at a few specific examples of ecosystems, and then we'll talk about a reference platform that we're currently developing above and beyond the existing RTG4 development board. We also want to ask for your feedback on a variety of things. So we realize that this is pretty much a one-way communication medium here, but we want to open the doors for your feedback coming back to us as a supplier, because if we have the right products and the right solutions for you as designers, then you'll be successful, and if you're successful, then we'll be successful, and that's what we want. So our vision for space here, so there's an overarching goal, which is to help our customers be successful. And the biggest problems that, from our vantage point, that you, our customers, actually face is attempting to get more computing throughput in space payloads. What we've seen over many years of being in this business is that sensor resolution and communication channel bandwidth is just expanding almost exponentially. There seems to be an insatiable demand for communication bandwidth and an insatiable demand for sensor resolution. And when you're performing remote sensing, or when you're implementing a communications bridge in space, you're very often limited by the downlink bandwidth of the radio transmissions back down to ground. So this ultimately means that you have to do more signal processing in the payload. And so in the block diagram here, you can see there is a very clearly defined signal processing data path. It is a remote sensing application, but I think the same thing is true even if we were to be showing something quite different like a communications payload. You're going to be drawing data in at the front end. Here, in this case, it's a sensor feeding an analog to digital converter, and then doing some processing. In today's architectures, there's a lot of work being done in heterogeneous computing architectures where you do some preconditioning of the signal, do some heavy-duty signal processing. The architectures of preconditioning and signal processing are quite different, meaning that different products are required doing different stages of the algorithm. Then you probably need to do some compression and storage before transmitting the processed data to the ground link. And supporting all of that, of course, you need to have timing products that are feeding clock signals and timing signals at appropriate levels of precision into the signal processing chain. You need to be supplying power that's adequately conditioned into the signal processing chain, and you need to be gathering telemetry from all of the components throughout the entire system. So from a Microsemi standpoint, we have products that support the signal processing chain, our FPGAs and our oscillators and clocks, our discretes, our power modules, and our system managers, all performing very important and very unique functions in the signal processing chain. And of course, the partners that we have invited to the Space Forum and who have supported us in Space Forum today also perform very, very critical functions in such a payload architecture with analog to digital converters, memory devices, and things that aren't shown on the chart here, such as software tools, prototyping tools, and IP to support interactivity between different components or interconnection between different components. So this overall vision is what's unifying Microsemi as a company and driving our desire to create an ecosystem within ourselves and also with our partners. And that is what Hichem is here to talk to us about today.
Thank you. So looking at how to enable the space designers, the space community, to improve the throughput of the engineers and to improve the scalability of what they're doing so that they can ultimately be able to reuse what they have invested in as R&D and as qualification, as tests, etc. So that's one message. The other message is this is an investment from Microsemi to take the offering that we have above and beyond just the silicon and the reliability reports and the SU immunity or the radiation tolerance or the radiation immunity. We're providing a methodical way of looking at how to enable you with a complete offering that covers the silicon, that covers all the reports, that covers the expertise from training, design services, support activities. But we also work with technology partners. Ken just listed some. We work diligently on integrated design tools, both for hardware and software. And we're working on a large set of IPs that are not just any regular horizontal IPs. We go now to specific application IPs. So instead of just saying going towards all space with one set of IPs that one size fits all, we are now going down to the application level and focusing on providing the enablers in terms of IPs, etc. So if we look at the processing cores that we are offering, as you can see in this, we are covering a Cortex-M1 from ARM, the RISC-V from Sci-5, the Leon that you saw a presentation earlier. I put there Leon XX, be it the third or fourth generation fault tolerance or non-fault tolerance from Cobham or our friends in the Geisler BU of Cobham. We're also developing our own 8051S. The relationship that we're developing with all these partners is not just to get the access to the core, is to optimize the implementation of these cores on the different platforms that we are offering, using our tools, using our engineering resources and our design service resources to get to the best results out of these things. Now, if I go to the interconnect IPs, you saw earlier in the StarDND presentation the space wire and space fiber. We're developing ourselves the PCIe and bridges, PCI to PCIe, for example. We have serial rapid I/O activity that is ongoing in terms of optimizing some of the IP partners' implementation on RTG4. The JSD204, and when we have the JSD204, it's not just the IP, it comes also with the validation and then the ROP with the TI ADC, high-speed ADC that you saw earlier. So there is more activity on these interconnect. I just presented here the high-speed interconnect IPs, but there are a ton of other IPs that are readily available today that are low-speed IPs like the CANs, UARTs, SPIEs, etc., that are interconnect and interfacing with other silicon on the board. Now, in terms of really going deep dive in terms of applications, we have a list of exhaustive set of IPs that we deliver to you, readily available, that have been developed, validated integrated in many applications with some of our customers. And these IPs are available in the IP catalog. So the design that I mentioned here and I put in the block diagram is just simply stitching of all these IPs to implement a particular way of handling in combination with the LX7720 devices, 3 different motors or more. We can go up to 12 motors today with our implementations. And these motors can be different types. You can have BLDC, you can have stepper motors. We're also working on switch reluctance type of motors in terms of supporting the algorithms. That's one. 2, all these algorithms are not implemented in duplication and replication. We have time division multiplexing techniques that we're using so that the optimization and the implementation of the motor control is optimized and it doesn't take a big chunk of the FPGAs. And it uses fully the features and the characteristics of the LX7720 to provide a complete solution. Add to that the vital power supply and power supply management, the telemetry data, and the health of the board and the system in general. This is a complete offering from silicon, from IPs, from design activities. We deliver to you the whole RTL design with the IPs that are available in the catalog. So if now I step back just for the motor control applications, here is all the list of the enablers that we have. We have the kits, you see down there. You see the list of all the IPs that are available. We have a very highly skilled group of people that are specialized in motor control and customizing these IPs and helping you tweak in the parameters for the particular motor that you are using for your end applications. We have tools that enable you to do the debug and the tweaking for these parameters of the motors. And we have a ton of documentation, application notes, user guides. We deliver the schematics of the boards that we build for the motor control applications. Similarly, for a video, you have here a block diagram that shows the sketch of the video processing building blocks and the interaction with the display potentially. You could see that we have the major components that you will need to develop that. For this demo and the platform that we built around the video demo and actually reference platform, we used the RISC-V processor implementation in RTG4 to pipe clean the RISC-V delivery to the market, but also to do some pre and post processing and the order of the DSP operations that happen in the DSP blocks in the FPGA. Obviously, we need access to the memory in order to run the code of the RISC-V, and this is coming from our partner at Cypress, but we also have the vital functions for the power management as well as for the telemetry. If you look at the ecosystem now for the application called video, you have the list of IPs on the left. Bottom left, you have the RTG4 and the add-on video card that is plugged on the FMC card. You have the tools to monitor and change the parameters. In the example that you see for the picture there, it's showing an example how we look into a particular cup and then find the contour of the cup. Documentation, complete access to everything you want. And we have really highly skilled group of people that do video IPs and video customization for you. This is a signal chain, an acquisition and processing. I'm looking at the time to make sure that we are on time there. As you can see here, we have sensors. We have high-speed external ADCs coming from partners like TI. And the data comes at a very high speed that access SerDes. Then you have the JSD with all the latency requirements. All this data gets retimed. I didn't put the retiming block in there, but ultimately, before we go to the digital beamforming or to the FFT or whatever other DSP processing that you have for the data, there is a demultiplexing depending on the variety of parameters that you control the demultiplexing with. Once you get that stuff, there is a post-processing, potentially a compression. Then you either send the data out or you go and put that data through the DDR controller to the flash memory, external flash memory. All this is, again, available. You got the list of all the DSP IPs for video processing or for signal chain processing, sorry. You have all the boards. We have the RTG4 dev kit, but we also have the TI kit that will allow you to get the high-speed ADCs and do real-time management. With the Libero, you have the highlighted item there, which is the catalog of all these IPs available. And once you stitch them together, the tool will allow you to identify and debug if there is connectivity lacking or if there is anything you need to do. Obviously, all the simulation models associated with all these IPs are also available to you. Documentation, and we have experts in DSP processing that could be there to help you either customize the IPs or support you to improve the bandwidth or the throughput of the overall DSP processing. By the way, there is a section in my previous presentation that talks about how to get the best timing for DSP-oriented applications. And obviously, all the documentation required for that. So the theme is going to repeat itself again and again per application. You get the IPs, you get the hardware kits that you need, you get the tools that enable you to use and stitch these IPs, resources, engineering-wise, expertise-wise, that will help you customize and adjust and adapt. And obviously, we have all the documentation and everything you need in terms of reusing the work that has been done on the board to get there. Talking about the boards, we are in development and almost finalizing the architecture for the new space reference platform that we're developing. And I think you had hinted from previous speakers that we're going to add the telemetry manager or the space systems manager, the LX7730. We're going to put that on the board. We have the power and the POLs from Microsemi. We're considering getting the flash or the SDRAM memory from our friends at Cypress and our partners. And we're adding additional FMC connectors or FMC Plus in order to allow you to do to add add-on cards or data cards to the applications that you are developing, taking the TI add-on cards or taking the LX7720 cards and developing your own 3-axis motors or whatever you want. So the content of this is described in these bullets in the slide. But what we're looking for from informing you about this is to get your feedback as soon as possible, because we're finalizing the architecture here and we're going to go into the phase of developing the schematics and the layout for this board. So any feedback in terms of the ecosystem in general, but in terms of the reference platform that we're developing in the short term here, but in general, let us know if there are things that you need or you like to see because you need to use these things in your validation, in your certification of your systems or your applications and the satellite systems. Are there other enablers that we're not providing you today? Are there other issues, problems that you are not seeing anybody stepping in and helping you out in there? We need to be working with you to see if we have the possibilities to solve these problems for you. Microsemi solves complex problems, and we want to see some of the problems, the unique problems that nobody is trying to solve, or even if you are solving them today, it's painful, it's expensive, it's taking a lot of risk or requires a lot of mitigation that exacerbate your budget or exacerbate one of the issues that you don't want to see, like thermal or power or any reliability related things. So let us know, and we want to have, like Ken said, two-way discussion with all of you. Let us know what kind of other problems or ideas that we want to be able to solve for you and work with you to make sure that ultimately they get resolved. Whatever investment we're doing today, we do it in the right place to serve you better and allow you to solve all these kind of problems.